we were discussing about the pitch factor. Pitch factor means that coil span is slightly short of 180 degree, and why pitch factor, why coils, because we are telling from the very beginning try to make a full pitched coil 180 degree. But why that short pitched coil is necessary, that I will right now discuss. But before that I wanted to find out that okay, if somebody has made not a full pitched coil, but a short pitched coil, then the induced voltage, how much, by what factor it will be reduced. So, if you compare it with this, you will find that this is the diagram we drew last time. So, these lengths are all equal, this length and this length is equal. So, by applying simple geometry, this is epsilon by 2 and resultant voltage will be 2 E10 cos epsilon. And if it was full pitched, it is for short pitched resultant voltage. If the coil was full pitched, resultant voltage would have been 2 amplitude of E10, that is all. Magnitude of E10 and E1-0 are same. It would have been twice of that voltage. This is the phasor diagram of that. Therefore, the factor, the ratio of what? E 1 dashed, when magnitude of E 1 dashed, when coil is short pitched, divided by E 1 dashed when the coil is full pitched. This ratio is called, and this is denoted by Kp, and this, in this case if you substitute, these things will cancel and you will be left with cosine epsilon by 2. So, Kp is cosine epsilon by 2, but I have not yet told you why coil should at all be short pitch. Right now I will tell you, but you recall these two factors in any AC machines winding. One is Kd, which is sin m beta by 2 by m sin beta by 2. By that factor voltage gets reduced, and once again voltage may get reduced by a factor of cosine epsilon by 2, and which is called Kd. And if windings are distributed at the and with short pitched coils, then the factor, if windings or coils are both distributed and short chorded, each coil is short chorded and each coil is short chorded, the voltage will be reduced by a factor Kd into Kp. and this factor is called winding factor. Product of this K W is called winding factor. Understood? Now, I can easily tell you the reason why it may be worthwhile to go for short pitching. You recall that the B distribution in space is not purely sinusoidal. It will have space harmonics, and these harmonics are odd. Fundamental is first, the next predominant harmonic is third, and then fifth, seventh, and so on. Of course, their amplitudes are progressively decreasing. Is it possible then, by selecting a suitable short chording, can I eliminate one of the predominant harmonics? For example, if you have a two pole machine, P is equal to 2, okay, and number of slot is equal to say 12, then slots per pole is equal to 12 by 2 is equal to 6, and this is equivalent to 180 degree electrical. Therefore, beta value is known 180 by 6, that is 30 degree, is not? Suppose this point you listen carefully, we will discuss this at length, the same points often, but right now what I am telling, suppose total number of slots, this is total number of slots, okay. And suppose the slots are numbered like this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and this is of course circled, and after 12 once again 1, 2, 3, 4 in the developed diagram I should show. But the point is, suppose one coil side I place in slot number 1, this slot. If I want to make a full pitched coil, in which slot number should I place the return conductor? Full pitched coil means 180 degree. So, I have to move by 6, because 6 slots if you move, that will become 180 degree, and its return should be here, is not? Return should be here. So, a full pitched coil, if one coil side is kept in slot number 1, its return should be in slot number 7. They should be 6 slots apart. This is your coil. And this is a full pitched coil then. Full pitched 180 degree. So, 12 slots, 2 pole machine, 6 per pole, that is equivalent to 180 degree electrical, beta is 30 degree, angle between 2 slots, this and this are separated by 30 degree. Acha, I know that this is the Kp I have calculated cosine epsilon by 2, and as I am now telling you that the B distribution will have a fundamental, third, fifth harmonic. Suppose for kth harmonic, what will be Kp, kth harmonic pitch factor, it will be how much? Replace epsilon by k epsilon by 2, that is all. Electrically it will be much more now. Therefore, this is the pitch factor for kth harmonic. Is that clear? And in the expression of the EMF, net EMF across the coil, it should be multiplied with both Kd and Kp. So, suppose I decide I know that there is third harmonic, fifth harmonic, and I decide that I will try to eliminate the third harmonic voltage. Okay, let there be third harmonic be present in space, and that will cause induced voltage here. But if you want to annihilate the third harmonic voltage, one clue is here. Can I choose such a value of epsilon which will make third harmonic to so k pitch factor for third harmonic k 3 will be cosine 3 epsilon by 2. Can I make it 0? For what value of epsilon can I do that? Obviously, this will be 3 epsilon by 2 is equal to 90 degree, and I will say epsilon is equal to 60 degree. Therefore, I will try to tell that okay, while making the winding, do not make a full pitched coil, because in this machine I find third harmonic flux is very large, B is large suppose, and I want to see that no third harmonic voltage is induced. That can be done by making the appropriate pitch factor of that particular harmonic, try to make it 0, then you are sure there will be no voltage. In other words, what does that mean? Why that no voltage will come? Because that third harmonic poles for this arrangement of the conductors, if you do like this coil span. So, coil span make it 180 minus 60, and that is 120 degree, not 180 degree, 120 degree if you make, then okay, fundamental voltage will be reduced. There will be fundamental component Kp also, because the epsilon value is 60 degree for fundamental. So, that will be reduced by a factor cosine 30 degree, cosine epsilon by 2, no doubt. But you are sure there will be the pitch factor corresponding to third harmonic will be 0, because you have seen that while choosing epsilon value, that 3 epsilon by 2 is 90 degree. So, that cosine 90 is 0, and epsilon from there you got epsilon 60 degree. And why that will be? This is possible, no doubt, if this third harmonic fluxes are like this, then one conductor you can examine if it is 1 here, the other one is somehow under same north pole, it is returned. That is how it indicates that is how Kp 3 is 0 for third harmonic voltage, but fundamental voltage it will be there. But if you choose 180 degree, no doubt when if you consider fundamental voltage, one is under center of the north pole. Now, the return conductor 1 dash 0 will never be under the center of south pole, it will be under south pole only mostly, but it is not, voltage is maximized, it will be reduced. So, voltage induced gets reduced by both distributing the coils, which is taken care of by the distribution factor Kd, and it is also reduced because of use of short pitched coils. By what angle I will short pitch is decided by me. If I want to eliminate, suppose in the same problem, if somebody says okay, third harmonic, let it be, just for academic exercise I am telling, third harmonic I do not mind, let it be there, but what will be the pitch factor corresponding to fifth harmonic I want to eliminate. We will see in 3-phase machine, line to line voltage, even if third harmonic voltages are present in the coils, they do not appear in the line to line voltage. So, maybe at that time you will be interested to see that okay, fifth harmonic voltage I will try to nullify 0. And if you want to get the pitch factor for fifth harmonic, put k equal to 5 here, k 5, it will be 5 epsilon by 2 and try to set it to 90 degree, and then you will say epsilon is 180 by how much? 5. How much it is? 36 degree. But unfortunately, you can see for this machine we were considering the number of slots I told some 12 etcetera. Is it? Where that page gone? Oh, here only. So, angle between two consecutive slots, this angle is 30 degree, and for this machine it is 30 degree pitch for all the slots, and you look that okay, if epsilon is chosen 36 degree, then the fifth harmonic component of the voltage will be totally nullified. It will not appear across the coil. But however, you cannot short pitch a coil by 36 degree. Least number by which you can short cut a coil is a multiple of 30 degree. Anyway, this will not deter me to short cut the coil still. Why? Then what I will do is this epsilon whatever number I have got, I will try to see by what short slot angle beta, this is beta, how much it is close to integral multiple of beta. In this case, nearest value is 30 degree. Okay. So, I will shortcut it by 30 degree. Okay. It will not completely nullify that, but certainly cosine 18 degree, I mean if you do like that, that will be much less, because it will be close to not 90 degree, but around 90 degree it will become, because it is closest thing possible is 30 degree. In that case, I will choose 30 degree only, and it will reduce the fifth harmonic voltage considerably. That is the important point. Therefore, coils, after studying these things, we conclude that it is necessary to distribute the coils. Why it is necessary? Distribution of the coils primary means that you use more of the slots here, try to distribute the coils, that is one aspect. Second aspect is, if these coils are distributed, when they will carry current, they will also produce approximately sinusoidal B distribution, because a single coil, it is single rectangular MMF distribution or B distribution. But we have shown that if the many coils are displaced in space and connected in series, instead of keeping all the coils concentrated, the MMF distribution can be made a stepped ones, more towards a sine wave. So, that the effect of harmonics still it will be present, that will be considerably reduced, that is one thing. And why short chording? Short chording is necessary, assuming that space harmonics cannot be totally eliminated, there will be odd harmonics present like third, fifth, seventh, etc. And for a given number of total slots, number of poles, etc., I can calculate the beta. What is beta? Angle between two consecutive slots, or angle, this is same as angle between two consecutive teeth. Whatever it is, I know that beta. Therefore, the pitch factor I have found out for any kth harmonic, this thing it is cosine k epsilon by 2, then it tells me perhaps by choosing appropriate epsilon. What is epsilon? Epsilon is the angle by which the coil is short chorded, by what slot I will reduce, so that it will become short pitched by epsilon degree. So, I then try to say perhaps third harmonic voltage I want to reduce it to 0. In this case I am lucky, if it is third harmonic you want to remove, I will immediately say cosine 3 epsilon by 2 is 0, 90 degree, and it so happen epsilon is 60 degree. So, by 2 slots integral multiple of 30 degree is very much clear. So, if it is slots per pole is 6, full pitched coil means 1 7, I will place the return conductor not at 7, but at 5. Then it will be a short pitched coil reduced by 2 slots. It is short of full pitched by 2 slots, and then I will get it. If you want to eliminate say fifth harmonic, for some reason or other you do not like fifth harmonic, in that case what will be the case? Third harmonic I do not mind, I mean something academic exercise I am telling. If I want to reduce fifth harmonic, then I will try to examine by what angle I should short chord the full pitched coil. This is cosine 5 epsilon by 2, set it to 0 because cosine 90 is 0. Then I come out with an epsilon value which is not equal to an beta, a multiple of beta, say n beta, it is not equal to, it cannot be expressed like that. Therefore, there I am slightly disturbed because I am not sure what to do, but I am telling you. Then see this 36 degree nearest multiple of beta, this is close 30 degrees, 60 degree will be too high a value. So, nearest closest value of beta n is 30 degree, that is n equal to 1 of this one, it is integer any. So, use a short pitch angle of epsilon. So, the coil span will be not 180 degree, if you short it, it will be 150 degree, better use it, and then you are sure third harmonic or fifth harmonic voltage will be reduced considerably. You cannot get 36 degree, that is the thing. Therefore, I have now told you two very important factors and how to calculate them. There will be several problems given in your tutorials. Next topic will be, now we are ready to start a 3-phase winding, how it looks like. So, and we will try to make a 3-phase winding, and before that I will now change because you will see that a 3-phase balanced winding, if you want to make, it essentially becomes a number games very simple because in a very rhythmic fashion these windings which may look very complicated in one hand but after all it will become purely a number games. So, what we will do is this convention will follow. So far I was telling that I will name the conductor coil sides in this way. If one coil side here, I was telling that its written coil sides I was calling it 1 dashed, is not, that is what I was doing. But I will now slightly change that. What is that? That changing I have already done, one example I have taken. Suppose the total number of slots, no harm in repeating that problem, and p is equal to 2. So, I want to use full pitched coil. We will come to short pitched coil slightly later. Full pitched coil to be used, which means that coil span is equal to 180 degree. Electrical is obvious, electrical. So, how to calculate this angle? Calculate slots per pole, which is 12 by 2, and you get a number 7. Now, these slots are like this: slot, tooth, slot, tooth, slot. It goes like this in the developed diagram. And 12 such things are there. So, suppose this slot is 1, slot numbering will progress like this: 1, 2, this is 3, where I will place the conductors 4, 5, 6, and then let me draw so that this is 7, 8, 9. Okay, let me draw further. This you forgive me. It goes like this. So, 8, 9, 10, 11, 12, and after that once again it will be 1, and in fact before this it was 12, because circular thing I have unwrapped and put it on a plain paper like this. Now, what I will do, only this much I will tell, time is not there. What I will do is this: one coil side will be placed here, 1, and full pitched coil is to be used. Then its return other coil side must be placed at 1 plus 6, that is 7. It must be placed at 7. That is this coil, full pitched coil, will look like 1, it goes like this, and if you look from the top and it comes out, of course, it is a multi-turn coil. Say 2 turn I am showing. This is the thing. Anyway, I stop now, we will continue with this.